Well, hello, grade nines. We're going to carry on from right where we left off in the last class when we're solving equations. So in the last class, we just set up a math statement. Now we're going to give the questioner just a little bit more information, and we'll be able to actually find out the value of the unknown instead of just making a statement with it. So we're going to add on to our math statements from yesterday, a little more than yesterday. Hope everybody enjoyed their long weekend, and give them enough information to make an equation. Okay, so example 3, turn the following phrases into math statements. That should probably say math equations, and then we're going to solve. So 54 is increased by 2 times what number to get 98? So here's what we added on, and you'll notice that this is actually almost exactly the same question as we did at the beginning of the last class, but we've added on to get 98. So let's take a look and examine what we've got here. So first of all, what number tells us the variable we're looking for? So for our let statement, we need to say, let the number be n. So then we have to take a look and see if we know what each of these words translates into in math. So 54 is increased. So is increased is plus. And by 2 times a number, we've got 2 times. So I need 2 times what number is n. To get means equals, and then 98. So we've almost got the entire sentence, math sentence up there already. 54 is increased by 2 times a number. Now notice I don't use that little x in there. To get 98. Pretty straightforward, huh? Okay, and now we just have to solve this the same way as we would solve anything else. So I have to get the variable term by itself. So to get this by itself, I have to subtract 54 on both sides. That leaves me with 2n on this side and 44 on this side. And now to get the variable completely by itself, we're going to divide both sides by 2. And that means n is equal to 22. And since this is a word sentence, like a word problem, we should always end with a therefore statement. Therefore, the number is 22. Okay, hopefully that's pretty straightforward. So let's carry on. Here's the next question. The sum of 3 times a number and 1/3 of the same number results in 30. So here's what's been added from the last time we looked at this question. Results in 30, which is going to mean equals 30. What is the missing number? So again, we're going to always start with our let statement. Let the missing number be n. The sum of 3 times a number. So sum, remember, means that we have a plus somewhere, but we got to be careful with this one because it says the sum of 3 times a number and, so this is telling us the two things that have been added together, 1/3 of the same number. So let's try and turn this into a math statement. Remember, 3 times a number is going to be 3n, and 1/3 of the same number will be 1/3 n. We need 3n and 1/3 n, and since it's a sum, we put an equals in there, and it says the result, oops, not an equals, we put a plus in there, Here's where our equals goes, equals 30. Now, since there's a fraction here, remember how we get rid of fractions? We have to multiply through by a common denominator. Since there's only one fraction, the denominator I'm going to multiply by is just that one, 3. And don't forget, you have to multiply everything. This side needs a 3 as well. So that's going to give me 9n plus, this cancels with that, so it's just 1n equals, and 3 times 30 is 90. Collect up like terms on this side, so we have 10n equals 90. And then to get n completely by itself, we're going to divide both sides by 10. So in this case, our n equals 9. So therefore, the missing number is 9. Now at this point, you may want to pause this video and see if you can do the next few of these by yourself before watching the rest of the video. I am going to go through the rest of them on here, but take a few minutes and see how well you do. So looking at this next question, 54 is the difference between 12 and a number. So 54 is the difference. 54 is the same as saying equals 54. And it's the difference between 12 and a number. So here's the two things. We know that difference means subtract. And here's the two things being subtracted. 12 and a number. So let's do our let statement. Let the number be n. So I know I have to take a difference of 12 and a number. So 12 and a number, and it doesn't really matter which way we write this. If we have the number take away 12, or 12 take away the number, it has to equal 54. This is pretty straightforward to solve. We just have to add 12 on both sides to get the n completely by itself. And so that's n equals 66. And since it's a word question, we can say, therefore, the missing number is 66. Carrying on. The product of 6 and 3 more than 2 times a number. Okay, so be careful with this one. Remember, product means multiply. And then the next part of this is going to tell us what two things are multiplied together. So the two things being multiplied together are 6 and 3 more than 2 times a number. Those are the two things being multiplied together. And then it tells us that is 78. So we've got an equals 78. So let's take a look at this small thing here. 3 more than 2 times a number. Well, 2 times a number would be 2n, and I need 3 more than that, plus 3. Now, if you wrote 3 plus 2n, 3 more than 2 times a number, it wouldn't really matter. But usually when we see something say more, it means whatever's more is at the end of it. So let's do a let statement. Let the number be n. And now what have I got here? This says the product of 6 and 3 more than 2 times a number. So those are the two things being multiplied together, 6 and 3 more than 2 times a number, 2n plus 3. And it tells us that is 78. So now I have to go about solving, and this one has a distributive property part of the question. So I need to distribute the 6 through, so I'm going to get 12n plus 18 equals 78. And now we go about solving. So again, I have to get this by itself first. So I need to get rid of the 18. So minus 18 minus 18, which gives us just 12n on this side and 60 on that side. And then to get rid of the 12, which is multiplying the n, I do the opposite, which is divide by 12. Whatever I do to one side, I get to do the same thing to the other. So we divide both sides by 12, and I get n equals 5. And our therefore statement, therefore, the number is 5. Moving right along. If it costs $25 to get into the fair and $4 for each ride, how many rides can you take if you have $65 for the fare? Okay, so this tripped a few people up the other day when they're saying, I don't know how much, the unknown needs to be because we only had this first part of it. But we decided that the unknown was the number of rides, which now that we've added the thing on the end, it distinctly asks you what it is. So we need to use a let statement again and say let the number of rides be, let's let it be R this time, R for rides. So it costs $25 to get into the fair, so she starts with $25. And she has to pay $4 for each ride. How many rides can you take if you have $65? So she has a total of $65. So let's go about solving this. We got to get the 4R by itself first, so I'm going to subtract 25 off each side, which gives me 4R here and 40 over here. And then we're going to divide each side by 4, which gives us R equals 10. So therefore, she can ride, or she, I don't know why I thought this was a person, a she person, okay. Let's just change that, because I don't know. They can ride 10 rides for $65 spent on that day. Okay, carrying on. 18 less than 6 times a number is divided by 7 to get 6. So again, this is what we added on. To get 6 is going to mean equals 6. And we've got a couple things going on here. We have 18 less than 6 times a number, and that is all being divided by 7. So let's do our let statement because it's just a number we're missing this time. So let the number be n. 18 less than 6 times a number. Well, here's 6 times a number, and to get 18 less, I have to subtract 18. And then this whole thing is being divided by 7 to give us 6. So there's our equation. And the first thing we want to get rid of is any denominators, so I'm going to multiply both sides by that number 7, which cancels on this side. That makes it a little bit easier. So I've got 6n minus 18 equals 42. Now we're going to add 18 to both sides to get rid of this and get our 6n by itself. That gives us 6n equals 60. And the last thing we need to do to solve for n is divide both sides by 6. And so we have n equals 10. Therefore, the number is 10. All right, do we have any more here? Yeah, we got a couple more. Jonathan started with $500 in his bank account and took $12 out each day for lunch at the cafeteria. How many weeks until he's down to $200 in his account? So, until he's down to $200. So here's part that's giving us an equals. So that's telling us what he has in his account after a bunch of stuff happens. So let's start with our let statement. Let the number of weeks be W. So if we take a look, Jonathan started with 500, so he's starting with 500, and he took 12 out each day. Ooh, actually, this is getting a little complicated. This is how many weeks, and this is how many days. So I think we're going to have to make a little change here. It says let the number of weeks. I think we're going to have to go with days. Even though it asks for weeks, the variable we're going to use is days. So we'll figure out what we have to do afterwards. So he took out a certain amount each day. So let's let the number of days be, and I'm going to use a D for days to remind me that it's not weeks that we went up for here. So he's doing 500. He's taking out 12 each day, and we want to know how long until he has $200. So we need to get this by itself, so we're going to subtract 500 on both sides. And that's going to leave us with, don't forget about this negative, it's still there. Negative 12D equals negative 300. Now, it's important that you don't forget about this because otherwise you would end up with a negative over here and you'd wonder why. So don't forget when there's a negative there. And so now we have to divide both sides by 12, negative 12. And if we forgot about this negative sign here, we'd be dividing by 12 and we'd end up with a negative number, which would not make a whole lot of sense in this question. So 300 divided by 12, because the negatives are going to cancel, is 25. So that's 25 days. The question asked for weeks. Now, we're going to have to assume that this is a classroom situation or a school situation. If he's buying lunch at the cafeteria, I suppose it could be the cafeteria at his workplace, but how many days a week is he going to have to eat lunch, which is only 5 if he's buying it at a cafeteria for school. So to get weeks, we're going to have to take 25 and divide it by 5 because there's 5 days that he eats lunch in a week. So that means that it's 5 weeks until he's down to 200. So therefore, it will be 5 weeks until he's down to $200. Now, I actually suspect that this was a typo when I first put this question together, that I wanted to do days total. But this worked out quite nicely to an even number of weeks. Okay. Jordan gets a monthly allowance equivalent to 4 times her age plus $25 for her cell phone plan. How old is she if her allowance is $89 a month? So this tells us that whatever we set up has to equal $89. So she gets a monthly allowance 4 times her age. Whoops, let's do our let statement. Let Jordan's age BJ. So 4 times her age plus $25 for her cell phone equals $89. And this should be pretty straightforward to solve. I'm going to subtract 25 on both sides. So that gives me 4J left over and 64 when we do 89 minus 25. And 64 needs to be divided by 4 when we divide by 4 on both sides to get the J by itself, which means that Jordan is 16. 64 divided by 4 is 16. So therefore, Jordan is 16 years old. And I think that's the last question that we have to do together. It is. And so we'll leave you to that. You have your worksheet to work on, see how well you can do. And I will see you tomorrow.